Present. Okay, so as we have been doing for the past 2 weeks, and then this is our third week in this specific unit, which is entitled Triangular Trinity, we are concentrating on triangles, and then we're also concentrating on the Godhead 3 in 1 as we go about learning about triangles. My deep hope for this unit, and every week I'm going to remind you guys what is my deep hope, is that we may be God worshippers and idolatry discerners as we worship the Godhead 3 in 1 through the understanding of triangles and circle theorems. And this week we're going to work with triangle theorems. So we're moving a little bit more into the concept of idolatry discerners this week and next week. Biblical integration, we have talked about the creation. The Trinity was present at the creation of the world, and that is referred to in the Genesis, the first chapter. We have talked about the fall where people reject the Trinity. And I have mentioned to you guys, if we are praying and we only pray to Jesus and we only pray to God, what happens to the Holy Spirit? The Holy Spirit is just as important as God the Father and God the Son. And we talked about redemption and restoration. Now, redemption and restoration is more of a choice. We can choose to be redeemed and we can choose to be restored. Nobody is forcing us to do any of these or be a part of any of these things. But if we want to truly be one with God the Father, God the Son, and God the Spirit, we have to make the choice and the right choice to be redeemed, to make our choices that will make us go through redemption and face restoration. So now, what we have done in the past 2 weeks is basically we have distinguished between the trigonometric functions. In week number 2, we talked about sine, cosine, and tangent when you look at what they are and how we use them. Last week, we talked about angles of elevation and angles of depression. And this week, we want to determine the sum of interior and exterior angles. And we're going to be looking at the different properties of different polygons this week. And then essential questions. How do you see angles? How do you use angles to model and solve real life problems? Is geometry more like map making or using a map? Or is it like inventing and playing games like chess? And these are questions that, as the first 2 weeks have passed, this week and next week, we need to find and gather information for us to be able to answer these questions by next week, Friday. So now today is September the 13th, and we want to start our lesson. Basically, we want to talk about recalling the angle properties of triangles, quadrilaterals, and polygons. So basically, each shape, triangles have an amount of theorems, quadrilaterals have an amount of theorems, and polygons have another set of theorems. And what we want to do is that we want to be able to remember all of these terms so that when we go and we solve problems like what is in the second worksheet for this week, then we're easily able to relate. When I look at this problem, I know that I'm going to use theorem number 1, theorem number 3, or whatever theorem you're using. You want to distinguish between the property angles. So, for example, triangles have 4 different theorems. I want to be able to know the difference between theorem number 1 and theorem number 4. I want to be able to know the difference between theorem number 2, part A, and part B. And I want to be able to understand why are these theorems different from one another. And the last thing is that we want to evaluate problems using the angle properties. So now, based on all of the information that I'm going to give you guys on the 4 theorems for triangles, and the ones for quadrilaterals, and the ones for polygons, we're going to take all of those theorems and be able to solve problems like what is in worksheet number 2. So our topic for today is we want to concentrate on the properties of triangles. So today we're only going to talk about triangles. Now, what I'm going to be doing is that in the chat, I'm going to be putting a link to a game, and I want to know what you know about triangles. If you know the basics of triangles, because if we don't know the basics, then we can't move on. All right. So I am going to put this link in the chat, and it should take you guys to this activity. There you go. The link is in the chat. Click on the link. I'm supposed to have 28 persons in the game, right? Because I have 28 of you here. You click on the link and it will ask you guys to insert your name. So insert your first name.
Um, most of the click to click, and when I press quick, it just keep on say reloading, having some issues.
And then it might be your internet connection, Jesse. If you're not able to join because of the internet connection, the quiz will be there. You can try it later on.
No puedo, Messenger. Okay, miss.
If all you guys had to do was to click on the link, and then it should ask you guys to insert your name. If it's giving issues to you guys, it could be because of your internet connection that it's not going to load. I already have 19 persons and I'm missing 10 persons in the game. So let me see. Okay, I have 20. We're good. 21. Good. 22. Okay. So I'm going to put it again because I had some people that joined after I sent the message. So you click on the link and then it should take you to the game, all right? So, good morning, Eimer. I sent the link on the chat so you guys can go ahead and click on it. It should ask you guys for your name and then you should be able to join the game. All right. So we are going to begin the game, and I'm gonna press on start. I have Derek and Edmond. Okay, is somebody else trying to join? Because I will click on start and then you will not be able to join afterwards. Anybody else? Okay, good. So I'm gonna press on the start. In a triangle, how many total degrees are there? I'm waiting for two persons to put in their answers. Okay. Okay. So the correct answer should have been 180 degrees. How many degrees does a triangle have? 180. Shouldn't be, there is no percent. When you're talking about degrees, your answer should be degrees, right? So nobody should have put a percent. It does not vary. It always has 180 degrees. Maybe it might have different measurements for the three angles, but it will always add up to 180. All right. Next question.
360 is a circle.
Very good. And 360 is for a circle. Very good. So let's move on to the other question. What is the name of this kind of triangle? Right, isosceles, scalene, or equilateral? If you don't know, then you have to guess, right? I have three persons left. Haven't chosen answer. Go ahead, guys. Choose one. Okay, let's look at the answers. The correct answer should have been an equilateral. The triangle that you guys are seeing there, it has one little line on each of the sides. What does that little line represent? What do those little lines that are on the sides? Very good, Cesar. That means that all of them are equal sides. Next question. What is the name of this kind of triangle? And look at all of the sides. One side has one bar, the other side has two bars, the other side have three bars. What does that mean? What kind of triangle is this?
Yes, ma'am. What should we do with?
Arjel, you will have to wait for the activity to be over because I already started it and then you weren't able to join on time. So you will just have to wait, okay? Okay, so I am going to go ahead and end this one. Let's see, yes. Good, very good. And the answer is scalene. If we look at that triangle, all of the sides had different amount of lines on each one. One had 1 bar, the other one had 2 bars, and the last one had 3 bars. That means that all of the sides have a different measurement. All of them are different lengths. So because all of them are different, we call that an scalene triangle. All right? Next question. What kind of triangle is this one? Acute, right, obtuse, or robot? This one you guys should do it extremely fast because we have been talking about this non-stop. Okay, I'm gonna go ahead and close it. Very good. Some of you are moving to the top. It is a right angle triangle. Now, why is this not an acute angle? And I could understand why those of you put acute. It does have acute, but it has a right angle. And because it has a right angle, it is a right angle triangle. For it to have been an acute, all of them would have had to be smaller than 90 degrees. But this one has a right angle in it. That's why it has to be a right angle triangle. What is the name of this kind of triangle? Right, scalene, isosceles, equilateral. Okay, let's go ahead and close it. Okay, so the answer should be isosceles. Now, why is it an isosceles? Because there are little bars on two sides, meaning that those two sides are equal to each other. And because two sides are equal to each other, it is called an isosceles triangle. This is an acute triangle, an obtuse triangle, a right triangle, an isosceles triangle. Which one? Okay. Very good. Very good. The answer should have been right angle, guys. The right angle was right there in the picture. You should have chosen right angle triangle. Let's do one more question. Okay, this one is an equilateral triangle, and we had done this one before, right? So I'll have everybody just close the quiz, this activity. I know we have more questions there, but it was just a quick revision. I didn't delete some of the questions I didn't want, right? So everybody go ahead and close it, and then you can come back to the lesson. Okay, so now what is a triangle? I'm gonna go through this quite quickly because this should be previous knowledge for most of you. A triangle is a polygon with three edges, and because it has three edges, that means it has three sides. It has three vertices, which are three corners, right? It is one of the basic shapes in geometry. It is the polygon with the least side. A triangle with vertices A, B, C, D is denoted as triangle ABC. So those are just basic information about a triangle. Now, I can classify triangles into two different ways. I could give a triangle a name based on the sides it has, on the length of the sides, and I could also give a triangle its name based on how big its angles are. So we're going to talk about classified by sides first. Now, there are three different types of triangles, and these are basic knowledge, equilateral, isosceles, and scalene. In an equilateral triangle, the three sides are the same, and because the three sides are the same, the three angles are the same. And in the case of the equilateral triangle, all of them are going to be 60 degrees. 60, 60, 60. Why does it have to be 60? Why can it not be another number? Who can tell me?
Because all sides are equal.
Okay, but why couldn't it be 90, 90, 90 or 75, 75, 75? Why is it 60?
What is the question?
Why in the equilateral triangle are all the sides 60 degrees? I mean, all the angles 60 degrees. Why 60? Why couldn't it have been, I don't know, 50 or 75? Why does it have to be 60?
It's in the same angle, miss.
But why? I know that all of
Depending
them
of
are
the
the
triangle,
same.
miss.
I know that all
Okay.
sides are the same and all the angles have to be the same. But why is it always 60 degrees? Anybody
Miss,
knows
depending
why?
of the triangle.
This because it is an equilateral triangle, miss. All sides are equivalent to 60.
But okay, I know and we
For the
know and I
other
see that
angle,
you guys understand that that is the concept. But why 60? Why can't it be 75?
Miss, all sides equal. Because all sides are congruent and all ones out of them, like they all measure 12 centimeters.
Okay,
Miss, because the degrees of the triangle is 180.
okay, very good, Russell. Very good, Dylan. I said Dylan, put it in the chat. It is 60 because 60 plus 60 plus 60 gives you how much?
180.
And how many degrees does a triangle have?
180.
Very good. So now it has to be 60 because when I take the first 60 and the second 60 and the third 60 and I add it together, it gives me 180 degrees. And a triangle has 180 degrees, right? It cannot be 50 because 50 plus 50 plus 50 gives me 150. It cannot be 80 because 80 plus 80 plus 80 gives me 320. It gives me more. All right, so it has to be 60 and 60 and 60. Isosceles triangle. An isosceles triangle has two sides that are equal, and because it has two sides that are equal, it has two angles that are equal. And then the last one, you have a scalene triangle where all the sides are different. And because all the sides are different, all the angles are different as well. So these are the basic, and these are the ones that we learn in primary school. So these are the ones that they teach you: equilateral, isosceles, scalene. These are the ones that we have known from way before. All right. Now, what we want to do is that we want to add to this. We want to know how to classify triangles by their angles. So now we have acute triangles, we have right angle triangles, and we have obtuse triangle. Now, how do we know which ones are which? The right angle triangle is the easiest one to identify. Once you see that that has a right angle, okay, that is a right angle triangle. There is no question about it. But now the acute triangle, all of the angles, all of them, the three of them have to be less than 90 degrees. If I have one angle that is bigger than 90 degrees, it is no longer acute. It is no longer a right angle. So the acute, all three angles have to be less than 90 degrees. For the right triangle, it has to have one angle being 90 degrees. And for the obtuse angle, it has to have one angle that is more than 90 degrees. So that is how we know that these, how we classify them based on angles. So we have three triangles based on side. We have three triangles based on angles. But we can combine the names. So we can go a little bit more complex. And I could say this is a right angled isosceles triangle, where I am calling it isosceles and I'm also calling it a right angle because it has a 90 degrees and because it has two angles that are the same magnitude. It has two sides that are the same length. It is isosceles, but because it has a right angle, it is also right. So when I want to name this triangle, I'm going to call it a right angled isosceles triangle. Did everybody understand that? Was I clear with that? So now, what are the triangle theorems? And this is what we really want to understand, right? We want to get this clear. There are 4 theorems that we are going to talk about in triangles. 4 of them. Some of them are pretty direct and pretty easy to understand, but other ones have a lot of wording and need a little bit more of our comprehension skills to understand. So we're going to look at the first one. Theorem number 1 says the sum of the 3 interior angles of a triangle is equal to 180 degrees. We already knew this. This was previous knowledge. This was in our game. This is what I ask right now. But it is a theorem. And why do we call it a theorem? It's because it's like a law. You don't change this. It applies for all the triangles. So if I take the 3 angles of a triangle, angle A, angle B, angle C, and I add them, it's supposed to give me 180. If it does not give me 180, one of the magnitudes in that triangle is incorrect. All right? Number 2. I'm not going to look at this one right now. Let's move on. Theorem number 2. Theorem number 2 has 2 parts to it. It has part A and it has part B. Part A says, if one side of a triangle is longer than another side, then the angle opposite to the longer side is greater than the angle opposite to the shorter side. And I'm going to repeat that again because it was a lot to take in. If one side of a triangle is longer than another side, then the angle opposite to the longer side is greater than the angle opposite to the shorter side. And it's a lot of wording, and it goes back and forth with longer side and shorter side and angle and opposite. But the picture that I have here at the bottom explains what it's saying. If I have one side that measures 3 units and I have one side that measures 5 units, this is just saying that angle A is going to be bigger than angle C. Why? Because 3 right here is opposite to angle C. All right? So because 3 is smaller than 5, that means that C is going to be smaller than this one. I'm going to repeat it again. 3 is opposite to C and 5 is opposite to A. Because 3 is smaller than 5, then this says that C is going to be smaller than A. Did everybody understand that?
Yes, we did.
Okay. When we go to the actual problems, then you might see it a little bit more clearly. Part 2 of number 2. If one angle of a triangle is greater than another angle, then the side opposite to the greater angle is longer than the side opposite to the smaller angle. And I'll repeat it again. If one side of a triangle is greater than another angle, then the opposite side is to the greater angle is longer than the side opposite to the smaller side. So this is basically saying the opposite of part A. Part A said if I have a long side, then the angle that is opposite is going to be big. If I have a short side, the angle opposite is going to be small. So this is saying the opposite. If I have a small angle, the opposite side is going to be short. If I have a big angle, the opposite side is going to be longer. That is what it's saying, right? Theorem number 3. If any side of a triangle is produced, and when it says produce, it means that if I make it longer, right? If I extend a side of the triangle, then the exterior angle so formed is equal to the sum of the 2 interior opposite angles. So if I were to extend one side of a triangle so that it comes out of the triangle and I have this piece sticking out of the triangle, the angle that is made there is for me to calculate how much that measures, I'm going to take the two angles that are on the inside opposite to it, and I'm going to add them, and that is going to give me the magnitude to the exterior angle. And theorem number 4. The sum of the three exterior angles of a triangle is equal to 360. And this is exterior, outside of the triangle. So if you take a look at this question, angle 4, angle 5, angle 6 are the exterior angles, and because they are the exterior angles, when I add them, they should give me 360 degrees. Any questions? No questions? Okay. So what I want to do here is this, was somebody going to ask something?
Mom, it's clear.
Clear as mud, right? Because I feel like you guys didn't understand what I explained right now. Other days you're like, yes, miss, yes, and you're in the chat, yes. And today it's like, whew, like came in on one ear and came out on the other ear. Now, what I'm gonna use, I have about 10 minutes, right? We're gonna use the last 10 minutes. I'm gonna show you guys some visual aids. Maybe like that you'll understand what the theorems are saying. Before I go into that,
Gonna do the practice.
you are gonna do the practice until you guys understand the theorems. Because if we go into the practice and I tell you guys, find the magnitude of this angle, and you don't know what the heck you're gonna do, then we can't do it. So we still have to cover the properties of quadrilaterals, and we still have to cover the properties of polygons. So we have like about 9 more theorems to go, right? And then the activity number 2 that has the actual problems, then you have to know all of the theorems so that we can go ahead and do that. So let me share this one instead, right here. The interior angles are angles on the inside, right? The 3 angles have to equal to 180. So when I take these 3 angles, they should equal to a straight line, right? So angle A, angle B, and angle C should equal to 180 degrees. It doesn't matter how the triangle looks like. If I were to stretch it, it will always equal to 180 degrees. This is the first theorem that is shown to you guys, right? The second theorem talks about sides. So for example, let's say that I have something like this. This side is longer. And because this side is longer, this is going to have the biggest angle. This side is the shortest. So because this side is the shortest, this one is going to be the smallest angle. That is what number 2 is saying. And it goes the opposite way. If this is a very tiny angle, that means that this side is going to be the shortest. If this is a very big angle, like this one, that means that this side is going to be the longest. That is what the theorem was saying. Theorem number 2. Right? Theorem number 3 now. Theorem number 3 talks about exterior angles. Angles that are found on the outside. Right? So exterior angles are like the red, the green, and the gray that I have here. Those are the angles that are outside of the triangle. For me to make an angle on the outside of the triangle, I need to extend one of the sides. So that broken line has to be extended so that I can create the exterior angle. That theorem says that for me to calculate this red one right here, I need to add the 2 opposite on the inside. So for me to calculate this red one, I need to add this and this one. For me to calculate this gray one, I need to add this one and this one. And for me to calculate this green one, I need to add this one and this one. The 2 on the inside that are opposite to it. And then theorem number 4 says the 3 exterior angles, so the red, the green, and the gray, all of them should add up to 360 degrees. No matter how it looks like, I can change it. All of them should add up to 360 degrees. No matter how the triangle looks like, it will always add to 360 degrees. So those are the 4 theorems that we mentioned today. Is it a little bit more clear right now?
Yes, Miss, a little bit.
Yes.
Okay.
Little bit.
So tomorrow, what I'm going to be doing is that we want to cover the triangles completely. So tomorrow I do have some practice questions that I would like us to do, but I would also like you guys to go. We have 5 minutes, still time. I would like you guys to go to the worksheet number 2. I will share that right now. So you guys are going to see what I'm going to do right now. Worksheet number 2 has the shapes, is the one that has the shapes, right? Let me share this. Let me open it right now. So right here, you will go to week 4, learning activity number 2. And this is the worksheet. This worksheet has problems that it says angle property theorem word problems. It's not really word problems, but it has these ones. These are the first 3, and then you go to the other page and it has the following 3. It has quadrilaterals and it has polygons. So this worksheet has 12 questions. Tomorrow I will review the triangle theorems. I will review the theorems that I talked about right now. I will give you guys some practice, and then we will solve the first 6 questions that are on this worksheet. So what I want you guys to do is that you guys can go ahead and you can draw all of the shapes, but once you have the first 6, 1, 2, 3, 1, 2, 3, because these are the ones that talk about triangles. These are the 6 that I'm going to be doing tomorrow. All right. So we're going to review the theorems. We're going to do some practice, and then we're going to work on this worksheet. Only the first 6. In the following class, when we do equilaterals, I will do the other 3. And then in the following class, when we do the polygons, we will do the other 3. So this worksheet, we're going to do it piece by piece. Is everybody understanding?
Yes, Miss.
Good. So you guys should have for tomorrow 1, 2, 3, 1, 2, 3 drawn in your notebooks, and then space for the working. Clear instructions, right?
Yes, Miss.
Good. So that is the plan for tomorrow. Anybody has any questions? No questions?
So many are the judgments for 6.
Yep, you're gonna draw the first 6 triangles. Only the triangles. If you can go ahead and you can draw everything, but for tomorrow I want the first 6 triangles because those are the ones you're gonna work with tomorrow. All right? Okay, so have a great rest of day, guys. Enjoy the rest of your day. And I will see you guys tomorrow for class.
Bye, Miss.
Bye.
Bye, Miss.
Bye.
Bye, Miss.
Bye.
Bye, Miss.
Bye.